Okay, let's start today with a reminder of last time. So, if I want to graph f of x equals x squared plus 4x plus 3, remind me what the 4 steps are in graphing a function like this, which is a parabola. What's the first step that we did last time? Yeah, no, it's been a while, right? So we, ideally, if possible, just to get some points to sketch this parabola, the process we did last time was y-intercept, x-intercepts, then the axis of symmetry, then the vertex. Okay, so let's remind ourselves what those are. We have y-intercept first, x-intercepts, maybe intercepts. Then we have axis of symmetry. Then we have vertex. Okay, this was our 4-step process from last time. All right, somebody remind me, how do I get the y-intercept?
You set x equal to 0.
Set x equal to 0, absolutely. Okay, in this problem, when I set x equals to 0, only one thing is left, and what is that one thing? 3. Is everybody with me on that? 0 squared plus 4 times 0 plus 3. So when x equals 0, we have the point y will equal 3, so we have the ordered pair 0, 3, or the point 0, 3. That's one thing on our graph. Okay? So in this process, I'm gathering points to get a nice sketch of the graph. Finding x-intercepts. How do I do that? So y equals 0, or f of x equals 0, right? So that's going to leave me with x squared plus 4x plus 3 equals 0. Now, this is a quadratic equation, right? And so right now, how do I solve quadratic equations? I use something that we've used all semester long. It's called factoring, right? So you factor this out. Go ahead and factor that for me. This one's not too bad, right? You can use trial and error or the AC method. What do we get here? X plus 3x plus 1? Everybody agree with that? So that factors pretty easily, x plus 3, x plus 1. So I set both of those factors equal to 0, and I get 2 solutions, right? So what are my 2 solutions here? If I set this to 0, what do you get?
-3.
And this one?
-1.
Great. So I get 2 solutions, -3 and -1. Now remember, this goes with 2 points. So one point is -3, 0, and the other point is -1, 0. Okay? So now I've done 2 steps, and I have 3 points on my parabola already, which is great. Now I move to this step. Find the axis of symmetry. That is a formula that we learned last lecture. What is that formula? Does anybody remember?
X equals -b over 2a.
Perfect. X equals -b over 2a. And where did this b and a come from? The original equation, right? What's a? The coefficient of x squared is a. What is it in this problem? 1. The coefficient of x is b. In this problem it's 4. And c is the constant. Okay, in this case 3. All right, so x equals -b. So -4 divided by 2 times 1. So I get -2. Okay? So again, remember, that is a dotted line, x equals -2, that splits my parabola perfectly in half. And it's going to be a mirror image about that line. Okay? Then my vertex. What do I know about my vertex? 2 things to know. One is it's either the minimum value or the maximum value of your graph, right? Depending on if the parabola opens up or opens down. But also the x value has to be the same as the axis of symmetry because it's right in the middle, okay? So you can go ahead and take this x value here, -2, and put it right here for my vertex. Has to have the same x value. Now the question is, how do I get the y value or the f value? What do I do with this -2? Plug it in, sure. So you guys go ahead and plug that in for me. Plug it in here in this x squared and plug it in here in this x. Add that up and tell me what you get. So we have -2 quantity squared plus 4 times negative 2 plus 3. Go ahead and number crunch that.
You have our exams?
Yeah. Positive 4 plus negative 8 plus 3. What's that leave? Negative 1. I have 4 points. I have the axis of symmetry. This is great. This is plenty to get a nice rough sketch of this graph. Okay, so let's graph it. Okay, 0, 3. My y-intercept is right there. Negative 3, 0, and negative 1, 0. My x-intercepts. The vertical line, negative 2, is my axis of symmetry. So right here at negative 2, I have a dotted vertical line. Label that your axis of symmetry. Okay, and that's at x equals minus 2. My vertex is at negative 2, comma, negative 1, right here. Does this parabola open up or down? How do I know? What's A, right? It's all dependent on A. If A is positive, it opens up. If A is negative, it opens down. Okay? And hopefully looking at these points, it's going to be difficult to make this open downward, right? So here we go. A perfect mirror image about the axis of symmetry. And that's a great rough sketch of your problem. Okay? That's all stuff we did last time. Any questions on this? Okay, today we have another form and it's called vertex form. Okay? So the form we just did, and we did this all last class, was if it's written like this, ax squared plus bx plus c, you can go through our 4 steps and get a nice rough sketch. Okay? Remember, if you go through the 4 steps and you still only have maybe 1 or 2 points, all you have to do to get some more points is just do a quick table of values. Okay? Today we have another form for a parabola, and it looks like this: a parentheses x minus h quantity squared plus k. Okay? And this is called our vertex form for a parabola. So this a is still the same as that a. That tells you if it opens up or down. Okay, but the cool thing about this form is it's already in vertex form. So the vertex is h comma k. Okay? So just by looking at a function written in that form, you can tell what the vertex is. Right? Let's do an example. Sketch f of x equals x minus 2 squared plus 3. Okay? So let's take a look at this example. I'm asked to sketch the graph f of x equals x minus 2 squared plus 3. So first thing to notice is it's exactly in this form here. Okay, what is a in this problem, this example problem? 1. So a is 1. So we know it opens upward, right? X minus h. What is h here? 2. And plus k. K is 3. Now notice there is a minus already in the formula. Okay, so h is not negative 2. H is just 2 because the minus is already given in the formula. Okay? So what we know is just by looking at this equation, we know this is a parabola that opens up, and we know the vertex is 2, 3. Because it's already explicitly written in this form. Yes?
So you said h is positive.
H is whatever's sitting next to this minus.
Mm-hmm.
Yeah. So in this case, it's positive. Okay, what's the axis of symmetry, guys?
If it said x plus h, would that h then be negative?
Yes. Mhm. What's the axis of symmetry? Same rules as before. It has to have the same x value. So what would the axis here be? The vertical line, x equals 2. Okay? How many pieces of information do I have on this graph so far? I have the vertex. I have the axis of symmetry. If I wanted another couple of points, could I do that?
Yeah.
And how would I do that? Sure, do a quick table of values. Okay, here's my function right here. I can plug in some values, right? What if I plug in x is 1, for instance? What if I plugged in x is 0? What if I plugged in x is 2? Right? I could just plug in a few more points. What happens if I plug in x equals 2?
0. The axis is 0.
If I plug in x equals 2, 2 minus 2 is 0. 0 squared is 0. What's 0 plus 3? 3. Why did I get 2 comma 3? Because literally that's what happens, right? When you plug in x equals 2. But also we already had this point. Is everybody with me on that? I was just confirming a point that we already had. That's what I was asking. Okay. All right, let's plug in these points. If you plug in 1, what happens? 1 minus 2 is negative 1. Negative 1 quantity squared is positive 1. 1 plus 3 is 4. Let's plug in 0. 0 minus 2. Negative 2 quantity squared is 4. 4 plus 3 is 7. Okay? And of course you could get another couple of points if you want. But I think this is plenty to get a rough sketch. Okay? Let's go to the parabola now. Okay, the first point I was given this time was the vertex. So 2, comma 1, 2, 3. There's my vertex. So I know that we have a little dotted line going through the vertex. That's my axis. Okay? Those were the first 2 things I got because this was already written in vertex form. Now let's plug in a couple more points. 1, comma 4. 0, comma 7. And 2 comma 3, which we already have. Okay? So notice, I know it's a parabola. I know it opens up. I know it's a perfect image, mirror image about this line. So I think that's plenty. Let's just do a little parabola and try to make it a perfect mirror about that line, and you're good. Yes?
Sorry, I kind of missed it, but how did you put the axis even though it's x minus 2? Like how were you...
So the axis of symmetry
Yes.
is going to be the same x value as your vertex. So this vertex is 2, so my axis has got to be 2. Because if your vertex is in the center, it has to go through the center point. X equals 2.
Sorry.
Yeah. Okay? So now, if you're given this form, you can use last lecture. But if you're given this form, x minus h quantity squared plus k, you can do this. Okay, you can go right to the vertex, go right to the axis of symmetry. Sometimes that's enough. You could get a pretty good rough sketch. Okay? All right. Then there's another question. What happens if I'm given this form and you're asked in some of the later homework questions to put it into this form? Is everybody with me on that? So you're given the form from last time, but now you're asked to put it in vertex form. Okay? So that's a question we're going to answer in about 20 minutes. So you get to look forward to that. Okay. Let's move on to a couple more topics, and then we can come back and answer that question. All right, so far in this class, solving quadratic equations. So far in this class, believe it or not, there are 4 ways to solve a quadratic equation, and we've already done 2 of them. Okay? The first one is what? What's the usual way we've been solving a quadratic equation this whole class? Factoring. Okay? And then last chapter, we did another method that solved some equations. Let's remind ourselves what that looks like. Let's say I asked you to solve this equation, x squared equals 24. What method did we do to solve that? Okay, if you set it equal to 0, x squared minus 24 doesn't factor, right? So we wouldn't be able to use factoring. Square root property.
Yeah.
Square root property. We did this last chapter. So you take the square root of this side, you take the square root of this side, and what do I have to include on this side? Plus or minus. Great. So I get x equals plus or minus the square root of 24. Now, ideally, I would have you reduce that. Are there any perfect squares inside of 24? Yeah, we could split that up into 4 and 6. And the square root of 4 is 2. So your answer would be plus or minus 2 times the square root of 6. Okay? And again, this is a reminder. This is called the square root property. Okay? The square root property was also utilized to solve equations like this. X minus 3 quantity squared equals 25. This was another type of equation we utilized the square root property to solve. Okay? The process is identical. You take the square root of this side, you take the square root of this side, I gave you a nice number here, 25, and you do plus or minus on the number side. Your next line will look like this. X minus 3 equals plus or minus the square root of 25, which is 5. And now you have two answers. Question?
Why do we do positive negative if the 25 is already positive?
So what's going to happen is you're going to get two answers, right? And so if you just do the positive, you're only going to get one of the answers. So the negative answer is also going to work. Yeah.
Okay.
Because it's like,
You give 25 with the negative.
right, x squared equals 9. How many answers are there? There's 3 and negative 3. Does that make sense? So you want all the answers when you're solving a solution. Okay? Great, let's add 3 to both sides. And we get 3 plus or minus 5. This will give me my two solutions, which is what I was expecting. 3 plus 5 is 8. And 3 minus 5 is negative 2. Okay? So both of these methods that I just did, we did last chapter, which is called the square root property. All right? So that's method number 2, square root property. And that brings us to today's method. And today's method is the third method for solving a quadratic equation, and it's called completing the square. Okay? So we have solve by factoring, but what if it doesn't factor? Okay? We have square root property. Square root property only works when you have something squared equals to a number. Okay? Then we come to today's material. Completing the square works for any quadratic equation. Okay? In next class, we'll do the quadratic formula, which also works for any quadratic equation. Okay? So that's the great news about completing the square and quadratic formula. It works for any quadratic equation. Solving by factoring only works if it factors, right? If it doesn't factor, you can't do that. And the square root property only works for specific ones where you have something squared equals to just a number. Okay? It doesn't have that x coefficient. Okay? All right, let's do completing the square. So write out these 6 steps for completing the square. So if you have an equation in this form, ax squared plus bx plus c equals 0, these are your 6 steps for solving that using completing the square. Okay. Step number 1, a must be 1.
Always?
Yep. Okay, so that's quite a big first step. A has to be 1. Now, what if a was not 1? What if a was like 4 here? Okay? Well, here's the thing, guys. You have an equation, and you can do whatever you want to both sides of the equation as long as you do both sides, right? And so if there was a 4 here, and I know I can't do this unless there's a 1 there, what would I have to do? Divide everything by 4. Okay? So if there was a 4 right here, I'd divide this by 4, this by 4, this by 4, and this by 4. And then I could continue on and do the problem. Okay? So, first step, a must be 1. Second step, yes, the x squared and x terms. So just get the x squared term and the x term on the left side by themselves. Okay? So I'll put on the left-hand side, LHS. So just get the x squared and x terms on the left-hand side, which basically means move the c over to the other side, the right-hand side. Okay. Then let's move on to step 3. Add to each side a special number. Okay, so we're going to add to both sides a very specific special number. And that number is this: half of the coefficient of x. So we're going to take 1/2 the coefficient of x, whatever that is, and then we're going to square that number. Okay? So you're going to take 1/2 of the coefficient of x, and then you're going to square that number. We're adding that to both sides. All right, step 4. Factor the left-hand side. Step 5. Apply the square root property. And finally, step 6. Solve for x. All right, please make sure you write that down, because I'm about to erase it so we can walk through a problem together. Okay? 6 steps to solving using completing the square. A must be 1. Get x squared and x on the left-hand side. Add to each side 1/2 the coefficient of x, whatever that is, and then we're going to square it. Factor the left-hand side, apply the square root property, and then solve for x. Okay? It's these same 6 steps each and every time we solve by completing the square. Everybody got this? Okay, let's do an example. X squared plus 8x minus 20 equals 0. We're going to walk through those 6 steps with this equation. X squared plus 8x minus 20 equals 0.
Is it 11.2 or?
3, I think.
Okay.
Yeah. Step number 1. A must be 1. Are we good?
Yeah.
Yes. Step number 2. Get just the x squared and x term on the left side by itself, right? So I need to move that 20 over, okay? Now watch this, because I want you to do 2 things. First, do what you're told. Get the 8x together with the x squared, but then leave some room, because we're going to add a special, our little magic number. We're going to add that to both sides, okay? When I add 20 over here, and leave some room, because I'm going to add this magic number to both sides. Okay? So at the end of step 2, we have the x squared and 8x term on the left side by themselves. And I've left a little room because I'm going to add a specific number to both sides. And when I add the 20 to this side, it becomes a positive 20, right? Is everybody okay here? Okay. What is 1/2 of 8?
4.
4? And what's 4 squared? 16. Is everybody with me on that? Half of this and square it. So I'm adding 16 to both sides. Okay? That's the most important step. That's the magic number that we have to add to both sides. Okay, now factor the left side. Go ahead. If you're a trial and error person, you're trial and error. If you're an AC method person, use AC method. Get that left side factored for me. The great news is it's going to factor into a perfect square. Get it factored. What do you get? X plus 4 times x plus 4, right? And what's another way to write x plus 4 times x plus 4? X plus 4 squared. So when I get to the next step, it says apply the square root property. Well, that means you should have something like this. Something squared equals a number, and then you're ready to apply the square root property. Okay? And 36 is a great number. Okay, so let's take the square root of both sides. We're doing the square root property now. You get x plus 4 equals plus or minus. What's the square root of 36? 6. Now the last step, step 6, is to solve for x, right? So let's move that 4 over to the other side. X equals negative 4 plus or minus 6. X equals, we get two answers, negative 10. Negative 4, negative 6 is negative 10. And negative 4 plus 6 is positive 2. Okay? So I solved this equation using the completing the square. Yes?
Do you have to go back and plug in those answers?
No,
Or-
you do not. Okay. Now you can tell by these answers, negative 10 and 2, that this original problem could have been factored, right? So you could have factored this one actually. But if I change this 20 to a 21 or something where it's not factorable, then completing the square will handle that, whereas factoring won't. Okay? All right, let's do one a little bit harder. The next couple, let's do a little bit harder. How about this one? 2x squared plus 3x minus 2 equals 0. Two x squared plus 3x minus 2 equals 0. Why is this one a little bit more difficult than the last one? A is not 1, A is 2, right? So I cannot do completing the square unless I make there be a 1 here. Okay? So to do that, I have to divide everything by 2. Which kind of stinks right here because I've created a fraction and that's not fun. But I have to do it. Okay? So step number 1 on this problem is to create a 1 there, I had to divide everything by 2. Okay, now I'm ready to do step 2. So put these guys over here by themselves. Add the 1 to the other side. And then leave little room to add a number to each side. Okay, so let's do all of that in one step. So x squared plus 3 halves x plus the magic number that I'm going to add equals 1 plus the magic number that I'm going to add. Okay? Okay, 1/2 of the coefficient of x. What does of mean in math? Of. Multiply, okay? So here's my coefficient of x. It's 3 over 2. 1/2 of, which means multiply, 1/2 times 3 halves, which is what? You just go straight across. 3 over 4. And then I have to square 3 over 4. So if I square 3 over 4, I will get 9 over 16, right? All right, so let's just make this a fraction. 9 over 16. Okay, that's my special number. Half of 3 halves is 3/4. 3/4 squared is 3/4 times 3/4, which is 9 over 16. So I need to add 9 over 16 to both sides. Okay? All right. I need you guys to do 2 things for me. Factor the left side. Make sure it's a perfect square when you factor it. And then add 1 plus 9 over 16, which means you have to get a common denominator. Okay? Go ahead. Take a minute and get that done for me.
Wait, how is it 9/16? Oh, exactly.
You take half of 3 halves, you get 3/4, and then you have to square 3/4.
Oh, right.
Yeah.
Right.
So get the left side factored for me. And then get a common denominator on the right side. Two things. Get this side factored. And we got to get a common denominator over here. Keep in mind, this is going to be a perfect square, so it should be pretty easy to factor. Okay. Over here, you have to get a common denominator of 16, so 16 over 16 will be 1, right? So let's do this. What's 16 over 16 plus 9 over 16? 25. Great. Those are great numbers, because I'm about to have to square root those, and both of those are perfect squares. Now over here, when you guys got this factored, what did you get? What squared gives you 9/16? 3 over 4. Okay? So this is how you should have factored it.
How did you get 3 over 4?
Because 3 over 4 times 3 over 4 gives us 9 over 16. Right? 3 times 3 is 9. 4 times 4 is 16. Okay? Now, if you want to check this, if I FOIL this out, should I get this to equal this? Absolutely. Okay? So if I'm concerned that I don't have it right, it's easy to check. Just FOIL this out. Let's FOIL this out real fast. Let's go to the side and let's FOIL it out. X plus 3/4 times x plus 3/4. X times x is x squared plus 3/4 x plus another 3/4 x. And then 3/4 times 3/4 is 9/16. So the question is 3/4 x plus 3/4 x the same as 3/2 x? Well, what is 3/4 plus 3/4?
6/4.
6/4. Is 6/4 the same as 3/2? Yeah. Just dividing the top and bottom by 2, right? So it is correct. All right. The way that I need you to write it, though, is x plus 3/4 squared equals 25 over 16. And now I'm at step 5. Apply the square root property. So apply the square root property here. Square root of both sides. Plus or minus on this side. And then solve for x. And then we'll be done. Okay? So if you take the square root of both sides, you get x plus 3/4 equals plus or minus. What's the square root of 25 over 16? 5 over 4. Okay? I'm running out of room here, so let's move it over here. So I have x equals negative 3/4 plus or minus 5/4. You're going to get two answers. Negative 3 over 4 plus 5 over 4, and negative 3 over 4 minus 5 over 4. Okay? So negative 3 over 4 plus 5 over 4 is 2/4, which is 1/2. Okay, I'll reduce that in just a second. And negative 3/4 minus 5 over 4, which is negative 8/4. Both of these can be reduced. Great. So my answers are 1/2 and negative 2. Okay? And again, if you have answers like this, that means it could have been factored at the very beginning. Okay? Because 1/2 and negative 2, those are both nice numbers. Questions on the square root property inside completing the square? That's why it's so important that you can do the square root property, because it's required as step 5 in completing the square. Okay? Are we okay on this? All right. Let's go back to the question I asked earlier in class. If I'm trying to do a parabola and trying to put it into vertex form. Let me grab an example for us. Okay, how about this one? F of x equals x squared plus 4x. Okay, now here's the question. Put in vertex form label vertex and axis of symmetry. Okay? So the idea here is we have x squared plus 4x, but I want to put it into this form. F of x equals a x minus h squared plus k, and that way I can read off the vertex because it'll just be h comma k. Okay? So I have this form, and I'm being asked to put it into this form. That's what this question wants you to do. All right. Well, here's what I do. I have x squared plus 4x I'm going to need to complete the square here, okay? But completing the square on a parabola is a little bit different than when you're solving an equation, all right? And I'll show you that difference right now. What's the first step in completing the square? Yeah, coefficient of x squared is 1. We're good with that. What's the second step? Yeah, so we don't have that because we don't have an equation, right? So what's the third step? Half of the coefficient of x and then square it, right? So when you're doing a parabola, it's a little bit different from the work we just did. You're going to take x squared plus 4x. What is the magic number that I want to add here? Half of 4 is 2. 2 squared is 4. But I don't have the other side of the equation to add the 4 to, right? So what I do in this, in a parabola, is you add the 4 and then you subtract the 4. Okay? So that's the little difference that we have to do with a parabola. So if I have y equals, and I'm trying to complete the square, you're going to add the magic number and right away subtract the magic number. Because otherwise we'd be changing the parabola. Is everybody with me on this? Overall here I'm adding 0, right? You can always add 0 or multiply by 1 in ways to help us. Yeah, question?
I was going to ask, is that just like adding 0?
Yeah, adding 0, so I'm not changing it. Right, exactly. Okay? So that's the little difference. We're going to add the 4, which is our magic number, and then right away we're going to subtract it. So we're not changing the problem. Okay. All right, now let's take these first 3 numbers, and those are going to factor into a perfect square. What do we get? X plus 2 times x plus 2, which is x plus 2 squared, minus 4. And there we are. This is the new form that we were trying to get. Okay? So what is my vertex? And be careful. So there's a minus in this formula, right? So my vertex is negative 2, and my k is negative 4, right? So my vertex is negative 2, negative 4. Okay? Does this parabola open up or down? Up, right? Because a is still positive, it's 1. So there's my vertex, and of course my axis of symmetry will also be at negative 2. Okay? So that's what you have to look forward to. You're going to solve equations using completing the square, solve equations using the square root property, and then playing with parabolas, and towards the end they're going to have some in this form and ask you to put it in vertex form. Okay? And that means you're going to complete the square, but it's a little different because you're going to add the magic number and right away subtract the magic number.
So how come it's negative 2 instead of 2?
Right, so in the formula,
Yeah.
see how there's a minus in the formula?
Mm-hmm.
So if I want to get that formula to fit exactly with plus 2, I have minus minus 2. Right? It's x plus 2, but this formula is minus, so you have minus minus 2. So the vertex is negative 2. Okay?
Because what about the previous problem? It was
The minus was already there.
That
Yeah.
was already there.
Yeah, so that's why. So, okay. So what was the previous problem? Y equals? X
minus 2 squared.
plus 3?
Mhm.
Okay. Now, and let's look at the formula. X minus h squared plus k. So tell me what h is in this problem.
2.
Yeah, right? Because the minus is already there. And what's k in this problem?
3.
Great. And now look at the new problem we have. We have x plus 2 minus 4.
Mhm.
So what's k here?
Negative.
Negative 4. But now, since there's a minus in here, and I need to tell you what h is, what would I have to put in for h to get this to equal a positive 2? And it would have to be a minus 2, right? Minus minus 2 will give me positive 2.
Mhm.
Because there's a minus already in the formula, if it's already minus, then h is just that number. But if there's not, then it's the negative. Okay, so that's a little tricky. So it's the opposite. Okay, are there any other questions?